आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
We bring you all a podcast series on STEM popularization, that is, science, technology, engineering, mathematics, and medicine, supported and catalyzed by the National Council for Science and Technology Communication, the Government of India. Program is produced by Media for Community Foundation.
This is Manjeet. Welcome back to the podcast from the Indo French Center for the Promotion of Advanced Research, also known as CEFIPRA. Now let's listen to them for more information.
I am Yashonath, also known as Yashonath. I did my studies in BITS Pilani, 5-year integrated MSc, and then I did my PhD in Indian Institute of Science, and then I was a postdoctoral fellow in Cambridge and University of Cambridge, United Kingdom, and Royal Institution of Great Britain in London, and then I spent 8 months at chemistry department in University of Pennsylvania, Philadelphia. And then I returned and took up the faculty position in solid state and structural chemistry unit, Indian Institute of Science, which was founded by Prof. C.N.R. Rao. In the initial part of my research at this place, we were doing computer experiments on diffusion of small molecules in zeolites, and we found something very surprising. One was that when the molecular diameter was varied, the diffusivity is generally decreased for molecules diffusing in any medium. In our case, it was the zeolite, porous zeolite as the host, and small molecule like argon, etc. were diffusing inside these porous zeolites. And when the diameter of the diffusing molecule or atom was increased, then the diffusivity started to decrease, which is the expected behavior. But then, when suddenly at some particular large size of the diffusant, the diffusivity suddenly increased rapidly and sharply, and that increase was something very surprising, which was then followed by further increase in the size. The diffusivity decreased rapidly and went to zero. So this anomalous increase in diffusivity when the molecule is very large is something which was till then not known, and we term this the levitation effect for reasons we'll understand a little later. And we tried to investigate this in significant detail, and we found that this maximum in the diffusivity for the larger sized diffusant is related to the bottleneck diameter of the pore network in which these molecules were moving. We looked at two zeolites, zeolite A and zeolite Y, and zeolite A has a 8-ring window as a bottleneck, and they have cage-like structures interconnected through these bottlenecks. This 8-ring window in zeolite A has 4.1 angstrom diameter, and the zeolite Y has also cage-like structure with 12-ring 12-membered ring zeolites as a bottleneck, which are 7 angstrom in diameter. And we found that when the diameter of the diffusant is comparable to the bottleneck diameter, that's when the molecule, the diffusant has a high diffusivity. Now, another characteristic we found was the molecule with the high diffusivity has also low activation energy for diffusion, and the molecule with low diffusivity has high activation energy for diffusion. So, these were all the results from computer simulations, computer experiments, and the question was whether this behavior is actually seen in real experiments. And there were many people suspecting that they won't be seen in real experiments. But we tried to see what are the experiments to do. In our computer experiments, we had kept the mass of the monoatomic diffusant constant and only varied the diameter, so that the effect of the diameter becomes clearly visible on the diffusivity. But when we do laboratory experiments, you can't vary only the diameter without varying the mass, because it becomes impossible to find a real molecule whose diameter can be varied without varying the mass. So we were thinking what to do when we suddenly found a suggestion from Dr. S.G.T. Bhatt of IPCL Baroda. He suggested that you can still do real experiments with similar conditions, under similar conditions, by taking isomers of a hydrocarbon. So he said, you take N-pentane, isopentane and neopentane, they have different diameters but the same mass. So we said this is a very good idea, and then we tried to choose, we chose those three molecules. We did the computer experiments and we found that neopentane, which has a larger cross-sectional diameter compared to N-pentane, has a higher diffusivity than N-pentane. And in fact, isopentane also has a slightly higher diffusivity than N-pentane, but neopentane has the highest diffusivity compared to all the other three, compared to the other two. We also calculated the activation energy, and we found that the activation energy for neopentane is the lowest. So the experiments to measure the diffusivity of these molecules, one can use various techniques like pulse-free gradient NMR, uptake measurements, or quasi-elastic neutron scattering measurements. But the molecular dynamics simulations which we have reported are on the time scale of a few nanoseconds, and they are comparable, or they can be easily compared with only quasi-elastic neutron scattering experiments. And therefore, we were looking for carrying out quasi-elastic neutron scattering experiments on similar samples. That means N-pentane in zeolite Y, isopentane in zeolite Y, and neopentane in zeolite Y. And Dr. Hervé Joubig at IRSE Lyon in Lyon was very active in measuring these diffusivities of various molecules absorbed in zeolites. So we wrote to him and he agreed for the collaboration, and then we submitted a proposal to CEFIPRA, AFCPAR, and it was refereed and reviewed and then accepted. And then the collaboration started, and we did the simulations and we found that that neopentane has the lowest activation energy and n-pentane has the highest activation energy, which is the prediction of the levitation effect. So then these samples were made very properly by Dr. Hervé Jobbik at Lyon, and then he went to Grenoble to do the experiments, and he carried out the experiments, and each experiment required for him to stay about a week in the facility, neutron facility, and day and night he would make the measurements, and then he will go back to lab and do the analysis. And to our pleasant surprise, we found that his experiments confirmed the predictions of the simulations, and this was the first proof of the existence of the levitation effect, first experimental proof of the existence of the levitation effect, predicted about 14 years before, in 1994, by our laboratory. And in 2007 or 2008, we actually had the results from the neutron experiments, which confirmed our predictions made in 1994. So we then wrote the manuscripts, sent them and got them accepted in Journal of Physical Chemistry B, Journal of Chemical Physics, and Journal of Physical Chemistry C. And these results, I'll give you a brief overview of the results now. When we wanted to collaborate with a good experimentalist, and Dr. Hervé Jobbik was one of the leading experimentalists in this area, and we were looking for some amount of support. So we submitted a proposal to CEVIPRA IFCPAR, and the project was refereed and finally accepted after some revision. And the support we obtained was very helpful for doing these experiments, and these experiments also confirmed the existence of the levitation effect, and otherwise these experiments were not possible to be carried out, because in India we do not have such facilities for doing the neutron scattering experiments, which with intense neutron beam, and also the visits were very helpful in understanding the difficulties the experimentalists face, as well as for the experimentalists like Dr. Jobbik, what are the difficulties that the simulations offer. And with these we developed much understanding of each other, and also we got the support for organizing a meeting on diffusion, in which many leading scientists could come and deliver their talks, and a good amount of discussion took place in this meeting, and it was extremely helpful. The IFCPR or CEVIPRA actually was very supportive and helpful in organizing this meeting. They found the place for organizing the meeting. They gave us all the support for travel and other things, and the meeting, so we didn't have to think about any organizational details. That was totally taken care by CEVIPRA, and we concentrated fully on the academic part, which therefore turned out to be a very good meeting. And still many people who came to the meeting still remember that meeting as one of the best. Thank you very much.
This episode is brought to you with the content support from Cefipra and the technical support from the Sparrows team. We extend our heartfelt thanks to the Director of Cefipra, Professor Nitin Seth and Dr. Payal for their continuous guidance and support. Stay tuned for more episodes and thank you for joining.
आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी